Hey guys, we're going to do some more graphing here in section 1.5. This is called special functions, but there's just four different kinds of graphs to worry about here. This first one here, constant, we've actually already done that guy, but he does make a special graph and we'll look at it here in a second. The greatest integer step function, I'm only going to talk about it in matching purposes. So in other words, these four graphs over to the side, we're going to match them up. We're not actually going to graph him. These two guys we are going to take a look at, though. But for now, let's just look at a little matching section here. So I'd like to think that you can tell this graph here in the upper left corner looks literally like a set of stairs. So if one of the names for the greatest integer function is also called the step function, that's kind of a no-brainer. So this guy right here, just going to write the number. That's number 2. That's greatest integer. So upper right corner graph, horizontal line. So that's called a constant. And here's why we call it a constant. Let's just say for the sake of argument that points down -2 units. Well, the y-coordinate over here for this guy is going to be -2 also. The y-coordinate here is -2. The y-coordinate here is -2. So in other words, it's -2 all day long. It's constantly -2. So that's what they call a horizontal line, a constant function. So for the third one, the key letter here is this letter right here. So which one of these shapes looks like a V? Well, pretty obvious. It's this guy right here. So that's an absolute value function. Always makes the shape of a V. Excuse me. And that last one, my best advice to you would be to think of it this way. It's more than one piece. It's separated. There's a left piece, there's a middle piece, there's a right piece. So that's why they call this guy a piecewise function. It's divided up into different pieces. Okay, so that's graph matching the graphs. So let's take a look at the equations or an example equation. We can match those as well. So I'm going to come over here on the right and just look at the equations first and see if we can figure them out. So if I start with this first one, and if you knew, and I hope you do, that these little straight up and down lines are, in fact, the absolute value symbol, well then, gee, that's an absolute value. Guaranteed. I'm going to skip that second one, come back to it in a second. So if we know f of x means the same thing as y, and we do, so we just talked about that. That's called constant because y equals 5. There's no x to plug in. You can't change it. It's 5 all day long. So therefore, it's constantly 5. The one down at the bottom, too many f of x symbols here by accident. Sorry about that. Has more than one piece to it. So something happens here when the x values are less than 0, and something different happens when the x values are bigger than or equal to 0. So it's more than one piece. So literally, more than one line means piecewise. Okay, which leaves this guy, and I'll left him for last, just because this might be a new symbol that you've never seen. So for that guy, hopefully you can tell that the symbol there are brackets. I'll make it bigger. So anytime you see a bracket, that stands for greatest integer or step function. Okay, and another way of doing it sometimes, depending on the book that you're looking at or the math teacher you're talking about, they will make them a double line bracket as well. So that's a terrible double line bracket. But those are both brackets, and double brackets are symbols for greatest integer. So all we're going to do is match that guy up. Not going to worry about graphing them. We're going to move down here, and we are going to worry about graphing absolute value graphs. And believe it or not, these are actually pretty darn easy. So you can look at this box with some notes here later if you want. I'm just going to cut to the chase and tell you if we're making this shape, a V shape, the guy that's down at the bottom here, I would hope you know probably is the most important spot. It's called a vertex. So the vertex, given an absolute value equation, is as simple as doing this. We're going to take whatever number is being added or subtracted inside, which in this case is a -3. We're going to change the sign. Then we're going to ask, hey, what number is being added or subtracted on the outside or on the end? And that's a -4, and we're not going to change the sign. And that's it. There's no math involved. So to find a vertex for an absolute value function, you change the sign of the guy inside, you leave the sign of the guy outside. And we'll go ahead and graph that guy. So 1, 2, 3, 1, 2, 3, 4. That's where the bottom of this V shape is going to be. Now, there are two ways. There's a shortcut, and I'll show you that here momentarily. But I want to show you a way, and hopefully somebody has taught you this along the way. An XY chart. And you can use an XY chart for any kind of graph. Doesn't matter. So if you're not sure what the graph's going to look like, you can always plug numbers in to find out what it's going to look like. Now, I like repeating the vertex. We already know this spot, but here's why I like repeating it. I'm just going to go ahead and pick numbers that are really close to that first number. And the reason for that is I want it to fit on the graph. So if I pick a big number like 7 or 8, it's not going to fit on my graph. So if I just start with numbers close to my vertex, say 3, 2, and 1, then I'm going to be able to come up with some good points on my coordinate grid. So all we have to do is take and plug the 2 in for x. So imagine there is a 2 plugged right there. That would say 2 minus 3, which is negative 1. The absolute value of negative 1 is 1, and 1 minus 4 is negative 3. You could use a calculator for this if you want. Most calculators have an absolute value symbol or function. So let's try the 1. I plug a 1 in. 1 minus 3 is negative 2. Absolute value of negative 2 is 2. 2 minus 4 is negative 2. So let's plot those guys. So 2, negative 3, that goes right here. 1, negative 2 goes here. Now, I'm going to go ahead and draw this, and maybe you can put some thought into why I'm not going to bother to do any more points over on the right side to get my V shape. Okay, well, here's why. Down through the vertex, this guy's called the axis of symmetry. And if you learned anything from geometry, I think I just spelled that wrong. I think it's 2 M's. My apologies. The axis of symmetry just is a reflection point. So if this point right here is 1 unit to the left of the dashed line, the matching point will be 1 unit to the right. If this guy that we plotted a minute ago is 2 units to the left of the dashed line, then that guy's going to be 2 units to the right. And that's it. I got my V. So it's just a matter of now connecting some dots. Keeping in mind we're doing a V shape, so it's not going to go forever down. It's going to angle back up. And that's it. We got it. Simple as that. All right, so for number 2, I'll go ahead and show you a shortcut here in a second. Now, here's the thing. I'm going to abbreviate V for vertex. And we always want to establish that guy first. I said this earlier, and I think it says in the box up here. It does say coordinate within, but let's be more specific. So earlier I said what's being added or subtracted inside. There's nothing being added or subtracted. So I'll tell you what to do with that 2 in a second. So it'd be really tempting to use the 2 as part of this vertex, but it's what's being added or subtracted. So do you see anything out here on the end? No. So there is nothing being added or subtracted on the end of that problem. So my vertex is 0, 0. Okay, now what's the 2 for? Well, let me ask you this question. What would the 2 be for in this equation if you had to graph it? That guy's the slope. So you can think of that number in front of the x the same way you do with linear equations, and you can still graph a slope. So if you want, it's up to you to be 100% sure. Let's say you forgot, am I supposed to use the 2 for a slope or not? You can always do this XY chart, and it always works. But I'm going to go ahead and say, well, this 2 is understood to be 2 over 1. And I'm just going to count up 2 and over 1, up 2 and over 1. Okay, now again, you have to keep in mind, though, we're making a V shape. And this spot right here was the bottom of the V. So I'm not making a straight line that goes straight down through there. So if I want to do an axis of symmetry, which, by the way, is optional, you don't have to draw this, it would be right down through the y-axis. And I know that if the guy on the right is 1 unit away from that middle line, and the other guy on the right is 2 units away from that guy in the middle line, then I can do my symmetry points, and I got it. Matter connecting the dots. Really should have used the line feature here, I'm thinking. That was a pretty ugly straight line, but it does look like a V nonetheless. So that's it for that one. I'm running a little low on time here, so I think what I'm going to do is I'm going to save these next 2 graphs for part 2 video, and we also have coming up piecewise graphs. Thanks for watching this one, guys. Stay tuned.